So mixed exercise 6, question 8, we're asked to prove this identity here. Now, usual advice with trig identities, start with the nastiest side and simplify it. Now here, I wouldn't say that this is necessarily nicer than this or this is nicer than this. So there's nothing much we can do there. We can pick either side and try and work from there. The other thing we can do is look at all the options first of all. So look before you start and try and get every possibility sort of noted, and it might help us out. So let's start by looking at the right hand side. What have I got? I've got a cosec and I've got a cot. So that's 1 over sine, this is cos over sine. So inside the brackets I've got two fractions, and the denominator of both fractions is a sine. So the inside of the bracket would turn out to be 1 plus cos theta over sine theta, okay? And then it's that lot squared. So the right hand side, in my head, I'm thinking, oh, it could be rewritten like that. I'm also thinking I can expand out, and if I do that, the cosec times the cot is going to be cos over sine squared. So I can't see anything particularly helpful there, but that's what we got. Over here, I've got a bracket, 1 plus something, 1 minus something, so I'm thinking difference of two squares, even though there's one on top of the other, but maybe I could do 1 plus cos times by 1 plus cos on the top and the bottom, and then I'd have a 1 minus cos squared on the bottom. Oh, and that sort of ties up with the right hand side, didn't it? Because we had a sine squared on the bottom of the right hand side. So that's everything that I'm thinking of for the left hand side and the right hand side. That's everything that springs to mind. So bearing that in mind, which way do I want to start? I guess I'll start on the right hand side. So if I times by 1 plus cos on the top and the bottom, so I suppose this is a bit like rationalising denominators, isn't it? We're using this trick of difference of two squares. So we've got that. The bottom comes down to 1 minus cos squared theta, and that's why we did this. We get a nice sine squared on the bottom. Now the top, let's factorise expand the brackets out on the top, I suppose. 1 plus 2 cos theta plus cos squared theta. Okay, that's not looking too promising. Maybe I should have left that as 1 plus cos theta all squared. Yes, I should. Of course I should. If I go back to looking at what we said on the right-hand side, that's what we said the right-hand side is, isn't it? So let's do that again. We get 1 minus cos squared on the bottom. And on the top, I get 1 plus cos theta all squared. That is 1 plus cos theta all squared over sine squared. And that is 1 plus cos theta over sine theta all squared. And now I just need to reverse those steps I did in my head before. Can I remember what they were? Well, it was 1 over sine plus cos theta over sine theta all squared, and there we go. That is a cosec theta plus a cot theta all squared, what we were looking for.